Welcome to Adapting Class. Thank you for deciding to watch this video. IV dose calculation, drop factor calculation is some concept you have to know. Something when you go to the world you're practicing, you have to apply it. For your nursing school and for the NCLEX, you have to master how to do it. How do you do it? Stick around. I will show you in the easy, straightforward way. I do these questions in order to teach you content related to that. Don't worry, I got you. If you watch this video, this will make it so easy in your nursing school you HESI your test. There's a way you can do it. Of course, they will give you a bunch of information. Not all of them are relevant. You have to pay attention to the question. The key word is in the question. How many drops per minute? This is your friend. That's all. Should the nurse set the IV rate? I don't care about it. The rate is this, something over a minute. That's all. That's what it means. The provider ordered what? 2 liters of 0.9 normal saline to be infused over 8 hours. The IV tubing has a drop factor of 15 drops per minute. How many drops per minute should the nurse set the IV? It's a pump. You have to be able to calculate it yourself. The way I do it, I think you have to think in dimensional analysis wise. Don't worry, it's a big word. Write down the answer choice they've given you in the key portion of the question. They said, what? Drop per minute. What does that mean? Write it in symbol. This is it. Drop per minute. That means your answer choice has to be in this form. Then you tell yourself, they've given me this. That means I have to make sure no matter what I do in the variable given, I have to keep the drop on top and the minute on top. What have they given me? 2 liters. That's your volume. Your volume is what? 2 liters of normal saline. And the time they've given you is 8 hours. I can tell that there's no what? Volume in the answer choice. Drop per minute. I don't see any volume, right? That means I need to get rid of my what? Volume given. In order to get rid of something, always keep it on top so that you can cancel it. How? Look at the volume given 2 liters and the drop factor, the volume is down. That means we have to get rid of the volume. There's no volume in these answer choice. It's just a drop per minute. Therefore, my 2 liters, I need to put it up and then I'll be able to cancel with the ml. But what is the problem? Write the rate to be given 2 liters over what? 8 hours. But you cannot do that because this is in ml. Therefore, convert the liter into ml. So I put 1,000 ml over 1 liter. That get rid of the liter. Now I have ml. Now the time in the answer choice is in minutes. I have 8 hours. I have to turn it into what? Minute conversion. I'll put 1 hour will give me 60 minutes. And that will get rid of an hour. Then I write my drop factor. That will keep my drop on top, 15 drops per ml. So that is what you're going to get, 15 drops per ml. Now look at it. Your minute can stay. You see, your minute stay. Your hour is gone, right? Your ml is gone. And now I'm left, and your liter is gone. What am I left with? 2 times what? 1,000. What? Times 15. What is on top? The only thing that is on top is the drop. Over 8 hours is there, times 1, times what? 60 minutes. This is all you have. You can see that 15 go into 64. So you have 2,000 over 32. If you calculate you'll be left with 62.5. What is the answer? They always tell you to convert it into the nearest whole number. 62.5 is 63. Remember, you don't have a half a drop. So 63 per drop per minute. So the answer choice is that. You don't get rid of the 5, so don't pick the 62. So this is the key how to do this. The most important thing to remember, 2 liters getting converted into 2000 ml. And then looking at your answer and using your drop factor to keep those symbols in place, right? And that will allow you to stay in the same form of dimensional analysis and be able to answer the question. So 63. There's another one. Same idea. What do we have? At what rate in drop per minute? Same thing, drop per minute. Should the nurse set the IV? Okay. And nurse is, a client is prescribed what? 500 ml. This is the volume of lactate ringer to be infused over what? 4 hours. So this is where the time you've been given. You've been giving the time so that it has to be what? Infused over 4 hours. This is my time. And the IV tubing has a drop factor of 20 drop per minute. And I told you, you see drop per minute, drop per ml. Since I need to keep the drops on top, that means I have to write this the same way, 20 drop per ml, right? In order to get rid of the ml, my volume need to be on top. So 500 ml over what? 4 hours. 4 hours. I don't need to convert this into another ml because it's just an ml. And so this will take care of it. But what I need is the minutes. This is 4 hours. So I'll put 1 hour here over 60 minutes. And then you multiply it by your factor. Then you can cancel. ml cancel ml. An hour cancel hour. So the only unit you're left with is the drop per minute. So you have 500 times what? 20 over 4 times 6. So that's what you have. 500 times 20 over 4 times 60. And if you calculate, you're going to get 41. So you're going to get 41.6. In order to make sure, because it's a drop, you don't have 0.6, this become 42 drop per minute. And this is how you do these questions. Straightforward content analysis using dimensional analysis. Don't let them trap you. You'll be able to answer any questions. Pay attention to the answer choice they're giving you. Drop per minute. Therefore, I need to start from there, from the back. That's my answer. And then look at the factor. If they change it, then you have to flip the drop over the ml. But because we're keeping the drop on top, I write this. Then you have to get rid of the ml. That means your volume has to be on top and your time has to be down. Dimensional analysis, answering these questions. Take care of yourself and good luck. Thank you for watching.